This tutorial discusses the differences between fission and fusion. Alright, so nuclear fission. How I remember what this word means is I look at the word fission and I think of the word fizz. When something fizzes, it breaks apart, it boils over. That's what's happening with nuclear fission. A large nucleus is bombarded, so in other words, it's getting hit by a small particle like a neutron, and then it splits into several smaller nuclei and neutrons. When that happens, a whole bunch of energy is given off, called atomic energy, and this is how one of the bombs were created, was through this fission. Fizz is breaking apart. So uranium-235 was bombarded by neutrons, and it splits into krypton-91 and barium-142. And at the same time, other neutrons are formed. Then those neutrons come back and hit more uranium atoms. And that just keeps going on and on and on. So the amount of energy that's produced keeps increasing. And this is what's referred to as a chain reaction. So here's the first bombardment. Krypton and barium are produced in that process. These three neutrons then hit three more uranium atoms. And then with each one of those, it produces krypton and barium and three more neutrons. And then those three hit more uranium, and so on and so forth. And that's why you get this fizzing, and that's why it reminds me of fizzing. But this creates a whole bunch of energy that could be catastrophic. Fusion is the exact opposite. So I said think of fizz when you think of fusion. When you think of fizz when you think of fission. When you think of fusion, think of fuse. Things are fusing together. So things are coming together to make something bigger. Now this is what's happening in the sun and in the stars at all times. When the atoms are coming together, a lot of energy, once again, is given off. And that's why we get the energy from the sun. This actually produces far less waste than other reactions. So like burning fossil fuels and whatnot. And so we can actually use this to create energy. So let's take a look on how to break down these equations. You're going to do fusion and fission equations the exact same way as you did the alpha particle equations and things like that. So the top numbers and the bottom numbers have to be the same. So 1 plus 235, that arrow means equals 137 plus some number x. Notice that there's a 2 in front of that neutron. Just like in algebra, we're going to multiply the top number by 2. So that equals 236 is equal to 139. X is then equal, plus x. X is then equal to 97. That's going to be the top number of our answer. Now the bottom numbers, 0 plus 92 is equal to 52 plus x plus 2 times 0. That means 92 is equal to 52 plus x. X is then equal to 40. We look on the periodic table and we look for element number 40, the atomic number 40, because our final answer is going to be 97 over 40. When we do that, we find that it's ZR. And that's how you do fusion and fission.